So everyone, since the beginning of history, has realized that humans have a mind. Where that mind resides has actually been widely contemplated in different places. Not everyone thought it was in our brains. So let me kind of explain to you some of the key people and some of the things that have happened that are making people wonder about this question. So Alan Turing is considered like the father of modern computers. There's a really good movie about him, which I really recommend, but he was really thinking about this. And actually people were thinking for a long time about, if you could actually make a universal machine, which is called the Turing machine after him, is consciousness computable? And Turing thought that it was, because essentially he thought that we were basically just thinking machines, and so we could make a machine that could do any sort of computation, then we can make a thinking machine. And as crazy as that sounds, he's the guy who actually had the vision to think about something like your cell phone or a computer that actually is a single piece of hardware that just by downloading new different types of programs on it, it essentially is a universal like switch, like a Swiss Army knife. It can do anything in a certain sense, right? Anything that is computable, it can do. So how do we solve this problem? Well, Turing took a very a pragmatic approach. He tried to make this as scientific as possible. He figured that if we can basically make 3 rooms where there's a person A, and there's a person X in one room and a machine X, and then you're basically allowed to chat. So he's envisioning Twitter or AOL Instant Messenger, but that dates me too much, but you get the idea. Google Chat. If you can Google Chat with the machine, you can Google Chat with the person, and if the person who's trying to determine it can't determine which one is which, then we know that a machine is conscious. Okay, that's his idea. But already you should be a bit skeptical of this, because we already have machines that can sometimes pull this off. There's a really interesting example of actually just recently how Google Assistant, like the technology behind Google Assistant that all our phones are sometimes linked into, it could actually fool a person at a restaurant by just acting and just having a conversation with them to make a reservation. And the person on the other side actually thought that it was an actual human. It was actually just an AI machine. And no one, I think, thinks that the Google Assistant has a sense of human awareness and a mind. Do you think that? Yet it can start to pass that. And that's the fundamental problem, because even if you can emulate all the actions of a mind, does that mean you actually have a mind? And what it really gets to is this fundamental problem, is that we all know that at least we ourselves have minds, because we have direct firsthand experience that we have a mind, right? You perceive that directly. Now, when it comes to actually perceiving other people's minds, that's a different question. But we can at least make this inference that Planago would call proper and basic, that other people have minds too. But what do you do with a machine when you don't actually know either way? There's not a good way. John Searle is a philosopher who really formulated that problem in what he calls the Chinese room experiment. It's a thought experiment. So imagine a person who's following rules out of a rule book to interpret squiggles. He doesn't know anything about Chinese. This is a very Western story, so if you actually understand Chinese, this will make no sense to you. You can kind of flip it around. But imagine like a dumb American in the room. Is that hard? Okay, imagine a dumb American in the room who doesn't know a thing about Chinese or what this is. He just sees squiggles on a page, and he's looking at a rule book and just manipulating these symbols. And then there's Chinese people who are kind of putting stuff into this room. He's manipulating symbols, or maybe there's a group of people doing it, and then they're spitting out stuff. And then, but through this process, it actually seems like he can have a conversation. And then Searle asks the question is, well, does this man actually understand Chinese? Right? And that's the fundamental problem, because most of us would say, no, he doesn't understand Chinese. and certainly the book he's reading stuff out of doesn't actually understand anything. It might encode information that he's manipulating. So he's really just succeeded in fooling the people outside that he understands Chinese when he doesn't. And that's the fundamental problem with the Turing test. So you can imagine a case where a machine can fool someone to thinking he has a mind when it really doesn't. Now, there's a couple other advances that have really pressed the challenge of this problem. One of them is advances in neuroscience. So everyone, since the beginning of history, has realized that humans have a mind. Where that mind resides has actually been widely contemplated in different places. Not everyone thought it was in our brains. Like Egyptians, they would actually they were more concerned about keeping the body intact than it was about the brain. So sometimes they would actually bury people without their heads because that wasn't the important part. Isn't that interesting? Anyways, we can't imagine that because we know that the brain is somehow connected to the mind. About 100 years ago, a little bit more, actually more than 100 years ago, maybe about 130 years ago, Ramon Hickel, who was a Spanish scientist or anatomist, he found a way to actually do a silver stain so he could look at individual nerve cells underneath a microscope. And he's a guy who is considered the father of modern neuroscience. He ends up getting a Nobel Prize. He was an atheist. He actually became a Christian later on in life. He wrote this really beautiful book called Notes to a Young Investigator, which is a little bit misogynistic, but everyone was a little bit at that time. So if you're a woman, I'm very sorry. but it's still a worthwhile read to just put an asterisk over that part. But he talks about, he gives advice to what it means to be a scientist. But what he did is he actually looked and just was studying the shape of neurons in our brain and came up with the idea that maybe what's going on is these neurons are processing information, the dendrites are getting information, integrating it, and then the axon is sending out information. That's how our brain works. And you know what? He's right. That's exactly correct. And so as we started to understand more and more of this, here's the thing though. The more and more we study neuroscience, the more and more it looks like a Chinese room. It looks like things that individually can't really give an account for a mind. They're certainly connected to the mind somehow, but it's not enough to give an account for it. And I'll tell you what's going on with artificial intelligence is creating the same sort of challenge too. So this is AlphaGo. So when I was in college, was the first time that Kasparov was beaten by Deep Blue, which was a computer that could actually play chess. A quick aside, when Alan Turing came up with the idea of computers and it got first implemented, they were pretty certain that there was two problems they wanted to solve. They wanted to solve natural language to be able to get a computer to speak and think, or use human language, and they wanted to get it to actually be able to play chess. And it's interesting what happened. They found out that getting it to understand English was not a 10-year problem like they thought. We still haven't solved that problem. And they thought that teaching it to play chess would be extremely difficult. You see what's going on? They're trying to make an analogy saying, well, everyone can speak English, so clearly that's easy to do. Well, I mean, if you're taught it. I mean, everyone can speak a human language, so that's easy to do. But chess, only a few people can do that. And so that's harder. And so there's like a very human sort of way of doing that. But it turns out computers can solve chess really easily. Now, they couldn't solve Go, because a lot of the problems that were involved in Go had to do with pattern recognition on a higher level, that you couldn't actually just play it out in chess and look at tons and tons of examples. But that's where this thing called deep learning comes in, where it turns out that's really good at pattern recognition in a way that surprisingly maps in important ways, not identically, maps in important ways to how the human brain works. You can train a neural network in a computer science sense to be able to pick up fuzzy things that are just patterns that you can't fully even articulate and understand. You can give like a computer an intuition. It's encoded in numbers. But what is it actually going on? I mean, what I said are all very valid ways to describe it, but it's all just matrix multiplications and simple math operations. It's actually fairly disturbing how mindless the process is. I remember when I first learned about matrix. You guys learned about that like as a sophomore in high school or so? I remember thinking this is the most bizarre thing in the world. Why would you manipulate numbers in this way? And they said, no, it'll be very interesting and useful down the line. It's very helpful for making sense of certain things in science. Hand waving a high school teacher doesn't quite know how it connects. Okay. The thing is, that basic operation of a matrix multiply ends up being the fundamental thing behind the most powerful machine learning stuff of today. Isn't that crazy? And it just has to do with tuning and tweaking the numbers in these matrices that you can do the most amazing things.